Yeah, you can share your screen. Aha, that's a typical data test. So you got what is it, in mechanical or electrical test experiment? This from this diagram looks like it's Ohm's law, right?
This is the BIL.
BIO.
What?
What for? BIO?
Force equals BIL.
BIL.
I know that this practical and like the theory around it is going to be in the data test.
So yes, okay, we can discuss what possible ways they might ask you questions. So what can you enlarge this diagram? I can hardly see the detail. It would appear there's have some apparatus. They got this is you know, they got a cylinder. What is a cylinder? It's just okay. That is measure the we have magnet. Yes, we have small, very tiny magnet. Okay, and we got cork, which is a copper wire. So basically, it's just what fixed to a pair of copper wire, and they have freedom to rotate, to oscillate.
It's connected to a circuit.
Because circuit, yes, that is a voltage. That is adjustable voltage, right? Okay, that makes sense now. So obviously they are trying to, yes, I can draw the better map than that. But can we just display what the method? Can we just read some wording? The contact is false, right? Magnet should be placed balance either side and construct a series circle including ammeter, switch. Follow teacher's instruction, ensure wire will be appropriate. Yes, we set how in place, zero the balance. Aha, the balance. So how can they balance these things? We set how place zero. Yes, but
zero the balance is like for the scale, I think.
How can I put it? How can we? Do you know how to put everything together? These are separated stuff. And
yeah. Because we did do this assignment thing.
Well, basically, there's a force acting on the copper wire, right? The lower part. Yes, I know that. Can you stop? I show you my side. I can draw that for you. It's not very clear though. This is just basically I'm looking for the built-up apparatus, which is wire. This is a copper wire, right? The copper wire is not connected with, forget about how to fix that, but basically they say they can be connected with a battery somewhere. And the battery is such that we can adjust the voltage. So that is the diagram they use, right? And it is a switch here, okay. And then you pick up the one end and another end is adjustable, right? Yeah, simple, isn't it? So this is positive and the current will move. Okay, show me which is the way the current will move. Can you draw?
Excuse
me. Yeah.
Oh, sorry. Can I have to take a call for a second? Is that all right?
Okay. This is just a battery connected with copper wire. Let's do the magnet first. Pair of magnet. So magnet. Maybe.
Hey, sorry. Okay.
So basically, I draw this diagram for you. So this is can you draw the direction of current? That's if you can draw, that would be good.
If the magnetic field is like.
That's right. That is the direction of can you draw the direction of current first?
Yeah.
You're right. This is a magnetic field direction. Oh, be careful. The current comes from positive to negative.
Oh.
So if you just follow that direction, so if probably this is different from your textbook, right? In my book, it doesn't matter. Both either way work. If I use this diagram, the current will be go opposite. That's right. The current will go that way, right? Oh, I see. So it's just matter how to work out the force acting on the copper conductor, right? So if you determine which is north, for example, if this is north to south, that's the direction of field, right? You got a pair of permanent magnet. So can we just assume this is north and this is south, right? Oh, that's simple. Can you work out the force acting on the copper wire direction? Yeah, it is upward. Yes, it is upward. Yeah. So which for can you write the formula? You know, so that is a current, and this is a magnetic field. This is a force. Yes, there's a formula for that. Yes, that's right. Sine theta. So what is theta in this case?
90, which is 1.
It's 1. Okay. Well, it's not clear, and they put the code here, right? I use different color, and they fix. Obviously, they fix this two wire, right? How can achieve the balance? What do you think? So this cylinder like cord here, so that they can fix this two wire. So how can they fix the balance? Do they have any mechanism to hold this cord at all?
It was the wire was tied to the cork.
It's tied to the cord.
Yeah.
So what can you measure?
We were measuring the weight of the thing and how it changed when we increased the voltage.
That's right. Yeah, that's right. So what's the point? If I, for example, I probably consider the simple way. If I have the weighing machine here, right? I just I wouldn't do that. So basically, what I can do is this. I probably upside down. No, I probably follow your teacher's diagram. Okay, if I were you, I just do this simple. I put the weighing machine here, right? The balance, digital balance here. I just put the cord here, right? The cord at the top, right? And then of course we just oh, the setup is different from you, but anyways, it's just it's my way to do experiment. So we just put the cord like this one. You see, upside down. You see that? And well, that is that's why I don't understand why they set up the experiment this way. Can we put a magnet over here so that we can generate a magnetic field in that direction, right?
I think it was so we could connect it to the voltage, to the circuit.
Yes, I know. So what's the point? You see, this can we go back to your textbook, because we cannot do any measurement. You see, how can you fix? How can you go to next page to see how they fix this core? And so this just yes, right. I mean, how can you fix everything? What is this disk? Does this disk, can this disk move or not?
This disc?
Yeah.
I think that was the scale.
Oh, that is scale. I see. That is scale. I see. Oh, I see. That's right. I didn't see that. So you put everything here, and this is fixed. Can you see? Oh, okay. I know. Can we? Oh, I cannot participate. Oh, cannot draw.
And then these are like the questions we have.
Yeah. Yes. Yes. No, can we draw the proper diagram for you? Can you stop for a while? I know what you're trying to do now. And it's a bit tricky because it didn't tell you, because it doesn't look nice. That's why I think the balance should be put downward. But what they do is, can we just withdraw this diagram slightly? So what they say, I'm right. So you should put this, the cause, that is fixed at the top. Okay, let's do it again. This is, so basically they have the stuff which is a what I call a disk, right? In this disk, they put a pair of magnet. Okay? They're just trying to interpret what their setup is. You see, on these two sides, they got a magnet. So one is north, one is south, so that they can generate magnetic field, which is attached. Everything is attached on the weighing machine, right? So basically, you can see digital here, right? You can see this number here. So what they have done, so this is a direction of magnetic field, right? And then what they did, they just put they just use another standard. They didn't show you. They should. So they should have show you to put the standards. You can see, put a stand here. And then we can, in that way, we should be able to fix. So, and we should be able to have some mechanism, right? To fix that core. That is very important. So this core is fixed. So you can imagine that this core is somehow fixed, right? Yeah. So that's a mechanism to fix that. Then what they did, they just put the core to a pair of wire, copper wire, putting through that. You see, that's how they do it, and that's that. In that way, they build this mechanism. Okay. And the power supply is not the issue. So the power supply must be somewhere else. I'm trying to figure out how did they do experiment first, and then we can discuss what they measure. So basically, they can. This is power supply, which is voltage adjustable. Okay, basically, you got, for example, this is positive, negative, right? So that is we got a wire connect to these two, right? And that's it. So the current in this case, current goes that way, go back, and current goes that way. Yes. So yes, in this force is upward. So that when you check, when you adjust the voltage, can we draw that properly? So this is this voltage is adjustable. Just do it. So it's just return to the diagram. So that is so basically they got the adjusted or pickup, right? And this is a resistor. This is a resistor. So that there is a battery. That's how they do it. Is that right?
Yes.
That's roughly, yeah, okay, I tell you now. Okay, you tell me what is going to measure. You can adjust the voltage, do you think? So hence we can adjust the current, right? Is the current is proportional to the voltage divided resistance of the copper wire. Okay. And then we can work out the force, the formula you have already. Okay. So as is a B, BIL or BIL, yeah. Sine theta. Yeah, I know what the experiment are doing now. Okay. Anything else? We have found the balance here, right? Because don't forget there's a disk here. They have also have certain weight. So can we just draw this diagram here? So basically, because the balance has certain weight, which is gravity, right? It's downward gravity. But in the meantime, they have adjustable, or they got the normal force, right? They got normal directional force as well. Yes. There's normal, so normal directional force, which is a balance, which can be balanced. But in addition, you got additional force, which is a magnetic force. You see that? So that's it. So what you read is just the opposite force. This is another pair of force. Can we say this is normal directional force. This is magnetic force. This is gravity, right?
Mm-hmm.
So this diagram is just for this disk. Can you see? That is for the disk. And but for the weight, for weighing machine. So there's a weighing machine here. So there's a weighing machine. Just to part of that, there must be the force downward. Can you see? So this force must be proportional or equal to, according to Newton's third law. What do you think? Is that what it's doing? So this is opposite to the n.
Yeah.
So according to Newton's law, during the balance, so these two forces must be equal in magnitude, but opposite in direction. That makes sense now. Do you agree?
Mm-hmm.
So if you, what did they change the current or did they change the voltage? They change the current, right? Can you check? Can you check it? They change the voltage. Okay. If that's the case, that is voltage is adjustable variable, right? So what you can see is that you will see response in the reading. You see that? So obviously there's depending on.
Oh no, we changed the current actually. Sorry.
You change the current. Okay, that's probably more direct to change the current. Okay, it's fine. If changing the current, the force will change, right? The force will change will reflect that in. Okay, that's it. Can you see that? Can you write Can you use Newton's second law to write the formula for this reading? So this is our reading, right? Everything you read from the balance, that's our reading. Okay. So what is the formula for the n you are going to read, which is in Newton? Or do they use in Newton or in gram? They can read the mass as well. Normally, this balance is used to measure the mass, right? So the unit is normally in the gram, right? Not Newton. Is that all? Not quite. You have to use this free body diagram. There are more than now. This is only true when I equal to 0. Okay? So this is special case. Imagine without the if there's because there's no physical contact, right? If there's no physical contact, then this force must be 0. You see, because the force. What do you think? I think you can tell me how did the measure how can the reading will be affected by the current? Without the current and this disk on the disk on the top of the balance is just his weight. Do you agree? However, if there's force upward, which is exerted on this metal, copper metal, right? Sorry, copper conductor. According to Newton's law, the reaction of force will be downward or upward. Actually, be downward, right?
Yeah.
Be downward. Yeah, that's why we made a mistake here. So this force should be downward instead of upward. Or are you sure?
Wait.
Because the force
the current would be the force would be upward because of the current.
Yeah, the force acting on the metal. Yeah, this is force acting on the copper. Is on the copper, right? On the copper wire, which is upward. As a result, because that is a force acting onward, so you actually push. Basically, the magnetic force is a push the wire upward. So according to Newton's second law, do you agree?
Yeah.
So there will be the word downward to the disk. Can you see? So that's why what I realized. The force will be downward. Do you agree? And this red color will be equal in magnitude, but opposite to this force.
Mm-hmm.
Can we use F here? So that would be the F dash, right? So F dash is again, so F dash is also equal to the F, but opposite in magnitude.
Yeah.
Oh, that makes sense now. Okay, can you write the equation to find the equation between the current and the reading, the N dash? So we just focus on this diagram, that's all. Can we just focus on this diagram? Because from this diagram, we should be able to find the N, right? Normal directional force. You need the help? Yeah.
Yeah.
Yes, so that's why I say, if I just use Newton's law, according to Newton's law, so we have used Newton's second law in this case. We got upward force is normal force. We have two downward force. One is F dash, another is the weight, right? And because it's balanced, therefore the acceleration is equal to 0. See, acceleration equal to 0. So that is the equation expected for. So based on this equation, we should be able to find that N will equal to mg plus F dash. You see that?
Yeah.
Or in other words, because they are equal in amplitude, so we can also rewrite this equation as BLI. Can put I here. That is the question we're looking for. Do you agree?
Yeah.
That's the question we can use to. Okay. So it is clear now. Can you return to your reference? So where see which data, what data is provided, or their experimental result?
I will find the.
Yes, that is the table, right?
Oh.
Oops.
And this is the data we collected.
It's connected, yes. So one is current, which is I, okay? Scale reading, which is in gram. I'm not surprising because the scale is used to measure the mass, not the force, right?
Yeah.
So therefore, you have to convert that into force. Anyway, that is downward is test 1, test 2. They have done 2 tests, 3. Force, you multiply 9. Did you type something?
9.9. The force of gravity. Yeah, times it by
9.8.
to get the force.
It should be 9.8 or 9.9.
9.8. I think
yeah,
she just wrote it wrong.
Yeah, 9.8. So the reason you have multiplied that is that this is a force. I can't write anything. Interesting. Oh, you have used this as a reading of mass. Okay, this table is terrible. the current, can you write I here? This I, this current is I, can you see? The scale reading, the scale index is mass, can you see? Mass in bracket in the bracket, the mass, yeah. And the force equal to the N in Newton, N is in Newton. So you basically have to convert that into that formula, right? Yes, okay. So what is the dependence? Do you know that is linear or quadratic?
It's linear.
It's linear because current is increased in linear. So can we go to a graph now? Yeah. The graph, yeah, it must be straight line with the slope, positive slope, right? Yes, that's it. That is data you can provide. From this data, what can you tell? Do you think the straight line is good model? A best one?
It's probably not the best one for these ones.
That's right. Because you got a finite number of data, so you have to work out the extreme. What is the minimum? What is the maximum slope? Do you know how to do that?
Yeah.
And then that's right. You can find the maximum and minimum, and they have to compare with what they're after. They ask for the percentage error. Do they ask for?
They usually give it to us. They asked for the uncertainty of the gradient and the uncertainty of the y-intercept.
That's right, y-intercept and the ingredient. So basically, you can, yes, that should be straightforward, isn't it? So how can you just go to whiteboard? You just perhaps go through this basic relation you might be asked. So basically, do you think they will ask you what is so we can we do this diagram first. So roughly this is diagram. Yes, it's data test. So you got the data, they will give you the several data here. Do they give you uncertainty as well?
They gave us the max and min lines.
Yes, that's maximum in line. So therefore, how can we work? So the question, how can we work out the maximum and minimum slope in this case? So that is how can we work? You have to, yes. Yes, actually that test is pretty simple, isn't it? Not much physics. Everything just come from, you just end up with work out the slope, right? You need to find the mean and also the maximum and the minimum, right? And the mean and the maximum minimum. So that will be that dependence. That is the current increase, right? The current increase and also the force increase. Not much to say. Anything else? Do you need for use a regression model use R square as well?
No.
No, they don't.
We had to calculate. I didn't know how to calculate uncertainty of y value.
Yeah. So there are two uncertainties. So in terms of uncertainty or percentage uncertainty, there are two of them. One is absolute, right? Absolute, can we call this a d? This is y, this is x. So they are looking for dy. So what's the dy? Or you measure the current as well. Can we just say the current? You see, you measure the current. So that is absolute. What is absolute? So you pick up the minimum, okay, or maximum from your data. Take the minimum, right? Divide by 2 as well. You see, that's right. That is absolute current. And because of propagation, and that will be affect. This also will affect your result, right? How can it affect the result? They measure both, right?
Yeah.
It's the same formula, isn't it? It's just the maximum minimum minus minimum, right? Divide by 2. I think in many cases you use this formula.
Yeah.
But another uncertainty is called the percentage error. Percentage error. Okay. Percentage uncertainty. So in this case, you have to work out the delta I over I, right? And the delta N over N, right? Anything else? There's not much to discuss today.
Yeah. How do we calculate the uncertainty of the y-intercept?
Uncertainty y-intercept. Well, you have to you have to use this data for the given data. This different pair of data is different, right? Can we just assume this is can we just use x and y, or what doesn't matter? We can use I and n. So if you put them together,
Because they gave us the max and the min lines.
yes. So the uncertainty, this should be a mathematical problem, right? How can the data test be used? So basically, you have to check the table. The table will give the pair of this data, right? So y is they will give a different number. How many tests? If you check the data test, oh, that's in this table. Let me just do the vertical table. You can check their table. So basically, they will give you this table, right? And they have how many tests? 2 tests, right? 2 tests. And so you have pick up this table. So in general, you have to this, for example, this is, they have particular number here. Can we just call x1, x1, x2, x3, x4, right? And you got y1, y2, y3, y4.
Yeah.
So you have to basically given that data, if you plot that data, that is you normally will see that more than if you have only 4 pair of data, right? So you got four data here, and then you can what you can do, you can pick up the extreme because this is average, right? You have this is a mean already. This is mean already. Basically, oh, I forgot. You shouldn't check for their arrow bar. That's how you get this slope, correct? Because in the, if you just draw this data, this just represents the mean, isn't it? Right? And you have this mean value that doesn't allow you to work out the variation of the slope and as well as interception. So what you need to do, you can work out this uncertainty first. You see, so each data have uncertainty. Do you agree?
Yeah.
So that is uncertainties will be give you some idea. For example, these will be for this one. These will be these will represent the. This is the mean. Can you see? This is the mean value, right? This is the mean value, and that will be the maximum. Can you see? For this is for particular y. Can I put the number here? This is for the fourth data. This is, they have 4 set of data. This is minimum, right? Once you have done that, then you can use the graphical method to work out the smallest. This is a little bit exaggerated. So you pick up the extreme, this lowest, to draw this straight line. Can you see? This is this will give you the largest gradient. And if you choose this two, if you choose another two, of course, I have exaggerated that uncertainty, right? If the uncertainty is 4, then that the variation must be very small. And that 2 straight line allowed you to work out the range of the slope, right? Of course, if automatically you can, if you insert the data, that gives you the best trend line fitting. That will, can we just draw another one, which is, can we use a red color? We should be give this one. So that with the mean, can you see? That is the mean, can you see? So basically you have to, first of all, to work out this, this is called arrow bar. You have to work out this arrow bar, right? We call it arrow bar. Arrow bar. Each arrow bar allows you to have 3 points, okay? So that is a little bit exaggeration. Of course, in this case, you will see that the y-interception varies, can you see? The y-interception is different. Did you notice that? Yeah. And from the slope of each line, you will get the gradient. So you can either use this slope, okay, this slope, or you can use this slope, or you can use this slope. Of course, I noticed that in the diagram you show me that the error bar is actually, the measurement is relatively accurate.
Yeah.
So in your case, probably your error bar is very small, not as big as I draw here. So your error bar is smaller, you see.
Mm-hmm.
So you are dealing with this relatively accurate measurement. You see, put another one.
Mm-hmm.
In this case, you can still work out the two extreme. You see, you can work out the two extreme. This is yen, two extreme. I have used purple. Is two is this is purple. So you still can work out this straight, this extreme. This probably the lowest gradient. All right.
Mm-hmm.
Just repeat that what I have drawn, and that the blue, the yellow one will be this one. Can you see? So probably in your case, the scenario, the data will be more look like this. That's what you can do. Okay. So in this way, you can find the three slope, right? And you can find the three. You can got the three y interception as well. Does that make sense now?
Yeah.
Yes. Can we return to your data? We will see any other questions they might ask. Yes, that's right. Can we look at the diagram first to see this is the same as, can you see? Can you see that they got error bar here? So they do use R square. Can you see? They use R square because R square is goodness. R square is the indicator how good the model is.
Yeah.
So they use linear equation model. Can you see? They use linear equation model. And this is obviously error bar. So this error bar can be determined from your experiment, right? For example, they measure 3-4 times. You have each measurement, they have 4 data. You pick up the maximum and the minimum, right? That and that will give you the absolute uncertainty. The mean value, the middle one will represent the mean value. You see.
Yeah.
So that is how they can you see they pick up this lowest slope by using this highest point for the first data and go to the lowest of last data. Can you see? In this way, you should be able to work out the 3 straight line. Okay, let's go to the question they ask. Yes, can you enlarge that? Identify the current through the conductor at which the average measured force is 1.1 Newton. Give your answer correct to the 2 decimal. So you have to use that. You have used this model now, right? You just go to the reading of current. What is current? The horizontal is current. What is the current one?
This one.
Yeah. What are you reading? Do you want to read the force or do you want to? What is the question?
We need to find the current where the measured force is 1.10.
Yeah, that's right. You're looking for the vertical 1.1. Okay, this hope is they got some detail. Yes, that is in this case you use the best fit, right? You use the best fit, not too extreme.
Yeah.
Okay. And can you use you can also because if they ask for 2 decimal places, then you probably it's easier to use this formula. Okay. If you just use the graph, I don't think you can confidently read the 2 decimal places. Yes. So use formula. Okay, use the best fit linear function. What is third question?
These are relatively easy questions, I think.
Okay, no problem. Okay.
But we'll go to this one.
Okay, identify, the mathematical, can you read?
Identify the mathematical relationship between the force acting on the conductor and the current through the conductor, including the uncertainty of the gradient and the y-intercept.
Yes, that is something we just discussed. Okay, so we got 4 sets of data, and we found the best fit straight line, and from there we should be able to uncertainty. So including uncertainty of the gradient. So that's what we're talking about. Uncertainty gradient would be, again, it's just use this formula that y equal to maximum minus minimum divided by 2. That is the formula they often use.
The mathematical relationship between the force and the conductor.
Well, mathematical equation just is a question we just derived today, right? Did you notice that? That is the mg take the force, which is L times yeah, that is a mathematical formula. Yes, in this case, what in this formula, what is m? What is c?
Oh.
Yeah. Can you tell me what is c? Oh, you can write the formula first.
C is the y-intercept.
It is y-intercept, but physically, what is c? Yes.
I don't know.
What is
I
m?
thought C was a constant.
Well, we do have a constant. Do you remember that constant? Can you stop your sign? You forgot. We just discussed. If I go to my whiteboard, we just discussed this formula. Can you see this formula over here? So mg would be the constant. Can you see? If you compare this with y equal to c plus mx, can you see? So this BL will be x, degree m, and mg will be c. Did you notice that? Okay, simple, right?
Yeah. So if we don't have that mass given, we just do it like mathematically.
Oh, you just if you're still not sure. So basically, the last question we discussed, they just ask you to use this formula. So this could be the uncertainty in this. You can apply this formula. Can we just apply this formula to if we just focus on the absolute uncertainty, so that we can apply this to the gradients. Can you see? So gradients, the gradients, you got delta m or equal to m max. You can measure the gradients, right? And minus minimum divided by 2. That's it. Also, y-interception, you can just you can use a yp, right? And the same, you just measure the 2 and found the this is the maximum, and take the yp, the y-intercept, which is minimum, right? Same formula. So when you work out uncertainty, you use the same formula. But of course, you have first work out this best fit equation. So what is m? You have found a number. Can you see that? You have found these 2 numbers first. Yep. Okay. Any questions? Any other question?
I know the data test is going to have like that formula and also projectile motion.
Yes, so it's 2 possibilities, right?
They're going to have 2 data sets.
Okay.
One's going to have projectile motion and the other's going to have.
Yeah, it doesn't matter. It doesn't matter. You basically need to prepare some to understand the physical equation. What is the physical equation behind that we discussed today? Do you want to discuss the project motion?
Yeah.
Yes, we can probably just review what you have learned in project motion, which is so what do they measure? Do they measure the angle, a launch angle? What is the variable? Do you have any idea?
Usually we have the launch angle and
angle is variable, right? Angle is variable. Okay. And how about the initial velocity? Is that the constant? So you can
Yeah.
change it. You can change it, say, can we say alpha? So this is U, right? That is the initial velocity. And anything else they want to measure? The range?
Yeah, and it's usually horizontal displacement.
Around displacement, that's called range. Okay, so that is this is the distance from origin to here, right? Okay. Yes, in this case, probably the dependence is not linear, right?
Mm-hmm.
Do you remember how to describe projected motion?
Sinusoidal.
Sinusoidal, that is also, oh, that is sine, depending on sine theta, yes?
Mm-hmm.
Yeah, yes, that's right. Do you know exactly what the formula is? So if you do remember, when we study the projected motion, we have choose a proper x and y axis. In this case, y axis will be vertical. And if you choose this origin at if you fix the cannon at origin, and it will be much easier. So basically, what that's basically equation for x is that they got. Do you remember? They have projection. They got two. Oh, you are starting the vector, right? So that's x component. Can you see? This is sorry. This is y components. One is a y components, another is x components, right? So in the horizontal, because we know in the projected motion, the force is always downward. Can you see that? The force is or acceleration is always downward. Is negative g. So basically, a, in other words, acceleration is equal to negative g, right? It's downward. It's downward. So therefore, because there's no acceleration along the horizontal direction, so therefore, the motion of x components, the velocity, the velocity x component will be always constant. That is ux multiplied time. Do you remember that?
Yeah.
For the y, because the acceleration is always negative g, so we can use this formula. We can use uyt take half g and t squared. That's it. That is the two equations to describe the projected motion. Of course, if you want to know the range, can you see what is the coordinate? Can you tell me what is the coordinate of the range here?
S of x.
Yeah, that would be r0. You agree? In our coordinate, that be 0.
Oh, yeah.
Okay. So what we do? Can we just net x equal to 0? No, sorry, not x equal to r. Sorry. All right. And also y equal to 0. We just use this coordinate. Okay. So yeah. we got r equal to uxt and 0, right? Equal to uyt. Can we factorize t? We can factorize t. We have factorized t here. We got this equation. You see that?
Yeah.
And that's it. That is so. Then we should be able to work out this relation. By the way, do you remember we are assigning vector? What is the component? How to write the components for x components? Given the angle is alpha. How to write the x components of this vector, the initial. So this is our initial velocity, right?
Oh, it's uxi plus uyj.
Ah, you're talking about the whole. Yes, that's right. If I can follow you. So basically, if you are writing the vector form, yes, I understand. So if you consider this this side is x, yes, that's right. This is what I say. This is a unit. This is I use your teacher's notation. So this is a vector. Yes, you are right. But my question is how to write these two components. What is the formula for these two components? You forgot? You see, that's why.
Oh, it's u
Yeah.
cos theta and u sine.
This is actually the projection. This is called component. This u cosine. What can you use theta? You use theta. We can use theta. Right?
Oh, alpha.
Doesn't
Sorry.
matter. Okay. Doesn't matter. You can. I follow you. You can use theta. Doesn't matter. You can use theta. Or you use alpha instead. Okay. All right.
It's in the thing.
Okay. So can you just substitute this formula in order to find the formula for the range? So what can we find the can we just combine this formula in order to find the dependence of R as a function of theta? You know what I mean? So what is
Yeah.
the relation? What is the C as function of alpha? Can you try to work out this function?
Mhm.
We got everything. Yeah.
Mm,
Can we simplify the second equation first, right?
yeah.
Because t cannot equal to 0, right? Physically, mathematically it's 0. So therefore, the second equation is simply equal to y equal to half gt. Do you agree?
Mhm.
Okay.
Yeah.
So we got r. Another you got u sine theta. Yes, it is alpha. So this is alpha, right? Alpha. Oh, they are not looking for the relation between alpha and t. They are looking for the relation between range and alpha, because that's going to be appear in the table. I guess that in this, if they choose this test, then they probably give you the table which has a different the dependence of alpha and the range. Can we eliminate the t? Can we?
Oh, right. I see.
Yes.
So it has to be a simultaneous.
Mm-hmm. Sine, cosine. Yes. Yes.
I'm not sure where to go from here.
Can we check? Can we just rewrite these two equations before we go further? So basically, from these two equations, right? We can r equal to u. That is cosine alpha, right? Multiplied by t. And from second equation, we got u sine alpha, right? Equal to half gt. All right. So if you just divide that on both sides, we can get rid of t. Do you agree? So if you use r divided by, how can we simplify this? R over, we solve the t, can we? we solve the t from second equation. So from the second equation, t were equal to 2u, right? 2u divided by g and sine alpha. Do you agree? We can solve the t.
Yeah.
Then we can substitute that into the formula. So that will do substitution. R will become u squared, right? 2u squared divided by g, and that we have sine alpha, cosine alpha. That's it. That is formula for the range. Can you see that?
Yeah.
Do you remember this formula? So how can we simplify this? 2 multiply sine alpha and multiply cosine alpha. Do you remember how to simplify this? In a trigonometry relation, how can we simplify this?
Does it equal 10?
No, equal to sine 2 alpha, double angle formula. Have you seen this formula before?
Yeah.
Yes. So that will allow us to write the simple relation of a range as a function of alpha. That will equal to 2u squared, not 2, we have utilized 2. We got u squared divided by g multiply sine 2 alpha. You see that? So that would be the formula for you. So this time it's not linear. You see?
Yeah.
So what can you do if it's not linear? Obviously, if you draw this diagram, go to the next page. So here we got this formula for the projected motion, which is u squared divided by g sine 2 alpha. It's not linear. So what can we do? Do you remember we do linearization? So if you use alpha directly, you will get so that the range directed with alpha, you will get something like this. Alpha equal to 0. Can you see? So we'll probably get something like that. Can you see? You agree?
Yeah.
It's not linear. How can we linearize? You know the linearization? Linearization. So this, yeah.
To linearize something.
Yes, you just rewrite this axis as a sine 2 alpha. Okay. So that will allow you to linearize the data. Probably got different data. Can you see?
Yeah.
If you do this linearization, that will give you the dependent axis. Can you see? Of course, you will see what the data looks like. But from this formula, we know that this is possible. Can you see?
Yeah.
So you should be able to follow the analysis we just discussed before. You still get it dependent. So they probably will give you the different, probably their data table, I guess, will be looked like this, right? They just have the, for example, different alpha, right? Alpha 1, alpha 2, alpha 3. And that made, then they will reach the range to measure test 1, test 2, test 3. Do you agree? And then they got the mean, and that will be similar. So the same analysis. So you have to find the extreme, right? You got the extreme, you got the mean, and then then in the meantime you should be able to work out the error bar for this measurement of range. You can see. You know what I mean? So the error bar is determined by this is the mean. Okay, this is a particular mean. This is I. This is the mean, and that's the maximum, is minimum. So same thing. So you should be able to draw the two extreme like this one, and another like this one. You see. After linearization, you should be able to do that. Okay. That's all?
Yeah.
When was test? Wednesday or Friday, right?
Oh, it's Wednesday, I think.
Wednesday. Okay. Oh, have fun. Okay.
Thank you.
Okay.
Okay.
Thank you. See you next time.
I'll see you next week. Bye.